Hello ladies and gentlemen. What we're going to be talking about today is how to name and write formulas for ionic compounds, but today we're going to be talking about ones that are I call type 2. Type 2 ionic compounds are compounds that contain transition metals. So, by the end of this video you should know how to name and write the formulas for those. So let's go ahead and get started. So, whenever you're writing the formulas for these type 2 ionic compounds or compounds with transition metals, you actually name them, you write the formulas the exact same way as you did the first types of ionic compounds or type 1. Basically, all you're going to do is you're going to put the cation first, followed by the anion second, and you're going to use the crisscross method. So remember what the crisscross method is when you're going to take the charge of one ion and write it down as a subscript on the other. But the difference in this now is that we're going to actually have to introduce the transition metals, which are compounds that have more than one oxidation state, or also called more than one charge. And remember that Roman numeral that's listed after the name is the charge of that ion. So here's two examples. We're going to look at iron 2 chloride or iron 3 chloride. So if you're given this name on a test, what I'm expecting you to do is I'm expecting you to give me the formula for it. So what I would need to do is I would need to write the symbol and charges for iron 2 and chloride for this first example, and then for iron 3 chloride I'd write the symbol and charges. So I do that here. So iron 2 means it's Fe with a +2 charge, and then chloride, I would just look on the periodic table. It's in the 7th column, which means it wants to gain 1 electron to get to 8 valence electrons, so its charge is going to be a -1 charge. And then for my Fe3, or my iron 3, it's going to be Fe with a +3 charge, and again, chloride, -1 charge. So what I'm going to do is I'm going to do the crisscross method. So I'm basically going to take the charge of my iron, and I'm going to write it down as a subscript on the chlorine. I'm going to take the charge of my chlorine, which is -1, and write it down as a subscript on my iron. So basically, remember, whenever you crisscross the charges, you don't include the pluses and the minuses. You just include whatever the number is, the absolute value, I guess. So it'd be FeCl2, okay? For the iron 3 chloride, again, same method, crisscross the charges. So I take a 3, write it down on the Cl, take the 1 from chlorine, write it down on the iron, but remember, we don't need to write ones. So there would be how you would write any, just really any ionic formula. You're going to crisscross the charges from the name. So that's the easy part. The next one that we're going to look at is we're going to look at naming chemical formulas when you're given the formula and now you need to actually write the name. The main thing to remember in this is that you have to specify the charge of the ion. For instance, for this one right here, CrCl2, okay? I can't just say chromium chloride. The reason I can't say just say chromium chloride is because chromium can have 2 charges. It can be chromium 2 or it can be chromium 3. So if I had CrCl2, well, that would be called chromium 2 chloride, or that sometimes is called chromous chloride. These are called Latin names. You don't need to have those memorized, but you might see it that way somewhere. Sometimes if you grab a compound off the shelf or something like that, it might say something like chromous chloride. Then CrCl3, that's called chromic chloride. So what I'm going to show you how to do is how to identify from the formula, how do I figure out the charge? Okay, so that's basically what I'm going to show you how to do. So how we find the charge is we're going to actually have to use the anion. So we're going to use the anion charge in order to figure out the metal cation charge. So here's my formula. Let's say I've got Au2S. So gold, Au, is a transition metal. Okay, it has multiple charges. So what I'm going to do is I'm going to use the charge of sulfur, or in this case, technically, since it's in an ionic compound, this is sulfide. So I need to determine its charge. Well, you can get out your periodic table. Sulfur is in the 6th column, or 6A, which means it wants to gain 2 electrons. So in order for sulfur to react with gold, it's going to have to gain 2 electrons, which means its charge has to be -2. Okay, so we know that sulfide has to be a -2 charge because of where it is on the periodic table. So then what I'm going to do is, in every ionic compound, there always has to be a balance of charge. What I mean by that is, the charge of the sulfides has to be balanced out by the charge of the golds. So in other words, if the charge of my sulfides is -2, that means the charge on my gold, like on my gold atoms total, has to be a +2. Now, since that is true, I can't just say, oh, this must be gold too, because that must be the charge of gold. What you have to pay attention to is the subscript as well. In other words, both of these gold atoms, when I add up their charges, they're going to be +2. And since I have 2 golds, basically what I'm going to do is I'm going to take the charge that I know my golds have to be added up together and divide by the subscript. So I take +2 here and I divide by 2. Well, +2 divided by 2 is 1. What that means is that my gold, the charge of my gold atom, or excuse me, my gold ion in this case, has to be a +1 charge. So that means the name of this would be gold 1. So I would call this gold 1 sulfide. The reason I would say gold 1 is because the charge on my gold in this instance is a +1 charge, and I would represent that by writing a Roman numeral 1 in parentheses, and then followed by my sulfide. Okay, so let's look at one more. So again, we're going to use the anion charge to find the metal cation charge. So now I have Pb3N4. Okay, so I know this is lead, and I know this is nitride, or nitrogen. So I'm going to use my anion. Well, nitrogen is in column 5A. So what that tells me is that nitrogen has to have a -3 charge. Okay, it's in column 5A. It wants to gain 3 electrons. When it gains those 3 electrons, it's going to be a -3 charge. So my nitrogen has a -3 charge, but there are 4 of them, which means I have to take -3, the charge on nitrogen, and multiply by how many nitrogens I have. -3 times 4 is -12, which means that's the total charge of all my nitride ions. Now I'm going to do the same thing that I did in my last problem. If the total charge of my nitrides has to be -12, that means the total charge of my leads has to counteract that. So that means they have to be a +12. So when I add it up, so since I have 3 leads here, remember this subscript 3 means that I have 3 lead ions. So when I add up the charges of those 3 lead ions, they have to equal -12. So in order to determine the charge on my lead, I would take my +12 here, and I would divide by how many leads I have. So I have a +12 charge that this has to be. I would divide by 3. +12 divided by 3 is +4, which means the charge on each one of my leads has to be a +4 charge, which means this would be called lead 4. So in order to write this name, I would call it lead 4 nitride. Okay? So, on this table, here's what I want you to do. After watching the video, after learning how to name and write the formulas, I want you to try to name FeO, and I want you to try to name SnCl4. And what you can do is you can just pause the video, take a little bit of time, try and write those formulas, and you can, I'll have the answers for them right here. Then I want you to do the opposite. I want you to take these 2 names, and I want you to write the formulas over here. Now this stuff in the middle you don't really need to worry about. It's just something that I kept track of. So you can go ahead, pause the video, try and name those 2 formulas, and then try and write the formulas for these 2 names. Then come back and I'll show you the answers. Hopefully you took some time to do that. So here are the answers, and you can check those. So that's all I have about naming and writing formulas. Hopefully you found this video helpful, and if you have any questions, make sure you let me know. Thanks for watching.